Okay, lesson 12, geometry. We're going to start talking about transformations, how shapes in geometry can move and change and shift. First of all, let's look at this problem. We're going to solve all of the angles, all of the missing angles. And I'm going to go through it. Actually, why don't you go ahead and try it? This is really a good quiz from lessons 1 through 11. So go ahead and push pause and see how far you can get. That was fun, but very messy. If you didn't get any of the letters, please let me know tomorrow, and I'd love to show you where all of the angle measurements came from. All right, moving on. Now we'll check out this shape. Okay, let's mark what we know. The measure of angle CDE is equal to the measure of angle BAC. We need to prove that the measure of angle DEC, I'm going to put a little dot there, is equal to the measure of angle ABC. All right, let's do it. So first we write down what's given. The measure of angle CDE is equal to the measure of angle BAC because it's given. We can also say that this angle is part of both triangles. So we can say that they are congruent. Measure of angle BCE is equal to the measure of angle, let's see, well, let's do this. Let's use the small triangles letters DCE is equal to the measure of angle BCA. Okay, they're the same angle. All right, now let's look at the small triangle and the big triangle. We're going to say for the small triangle, the measure of angle, oh goodness, CDE plus the measure of angle DEC plus the measure of angle ECD is 180 degrees. Now let's do the other triangle, the big one. Measure of angle BAC plus the measure of angle ACB plus the measure of angle CBA is equal to 180 degrees. Okay, back, this is what we're trying to get to, right? All right. Okay, when you have a whole bunch of angles equal to 180 and a whole bunch of other angles equal to 180, you can set those two, the left side of the equal signs equal to each other. So that's a lot of writing, that's okay. I'm just writing the first, I'm writing all of this, which is equal to 180, is going to be equal to all of this. Measure of angle EDC is equal to measure of angle BAC, measure of angle ACB, measure of angle, that's messy, okay, and that's just substitution. Property of equality. Okay, now we're going to subtract some stuff. Alright, we know that CDE is equal to BAC, so CDE is equal to BAC, and we know that DCE is equal to BCA. BCA is right there, and DEC don't see. Where did we lose DCE? Hold on. Let's find DCE. It should be somewhere in this one right here. So I think I might have made a mistake. DCE. DCE. Let's see. I did CDE, DEC, and ECD. So I just recopied that wrong. Yep, right there. This should be here. So that's a mistake. This should be ECD. Okay? I didn't recopy it correctly. Okay. DCE is equal to BCA. BCA, which is right there. So I'm left with these two. The measure of angle DEC is equal to the measure of angle CBA because of the subtraction property of equality. And in essence, that just means that I don't think I needed this one at all. Cool. All right, there's a mathematical modeling exercise that we are going to do together tomorrow. So I'm going to pass out some stuff and we'll work on it tomorrow, but I just wanted to remind you because you're going to see it in your classwork, but we will work on it tomorrow. All right, so let's look at our discussion. So it's critical that students understand transformations as functions that take a set of points as inputs, apply a given rule, and output a new location for the image of the input points. Okay, the input points don't move. The input points don't move, nor does the plane, which is what you're, drawing it on. So let's look at this. Explaining how to transform figures without the benefit of a coordinate plane can be difficult without some important vocabulary. So let's review our vocabulary. The word transformation has a specific meaning in geometry. A transformation, f, of the plane is a function that assigns to each point P of the plane a unique point, f of P in the plane. Transformations that preserve lengths of segments and measure of angles are called basic. I'm going to say this. Basic, rigid motions. Okay, rigid means that they're not bendable or flexible. A dilation is an example of a transformation that preserves angle measures but not the lengths of segments. In this lesson, we will work only with rigid transformations. We call a figure that is about to undergo transformation the pre-image, while the figure that has undergone the transformation is called the image, which the image is the after, okay? The pre-image is the before. Okay, our first example, rotation. Okay, using this figure, identify specific information needed to perform the rigid motion shown. So for a rotation, we need to know the center of rotation, the direction, clockwise, which you can say CW, or counterclockwise, which you can say CCW, and the number of degrees rotated. Okay, actually that doesn't go there. There we go. Cool. Yep, so center of rotation, the direction clockwise or counterclockwise, and the number of degrees it rotated. Okay, reflection. For reflection, we need to know the line of reflection acts as the perpendicular bisector of each segment, that joins a given vertex of the pre-image with the respective vertex of the image. Remember, the image is the last picture. And then lastly, the translation. That's 2 words. The point P to be translated the length and degree measure of the angle that the vector that makes with the line that passes through P and the endpoint of the vector. And that'll make more sense as we get an example. Awesome. Okay, there are some geometry assumptions that we're going to make. We've now done some work with all 3 basic types of rigid motions: rotations, reflections, and translations. At this point, we need to state our assumptions as to the properties of basic rigid motions. So any basic rigid motion preserves lines, rays, and segments. That is, for a basic rigid motion of the plane, the image of a line is a line, and the image of a ray is a ray, and the image of the segment is a segment. Any basic rigid motion preserves lengths of segments and measures of angles. So you're not going to change a shape. You're pretty much going to just move it. I've always learned that translations, another word, would be a slide. Okay? A reflection is like a mirror image. And a rotation is a turn. Okay? A turn, a slide, and actually I've always called that one a flip. So a turn, a slide, and a flip. Okay? So we're studying basic rigid motions right now. And if you look at the relevant vocabulary, we have a basic rigid motion is a rotation, reflection, or translation of the plane. Basic rigid motions are examples of transformations. Given a transformation, the image of point A is the point the transformation maps A 2 in the plane. Distance preserving, a transformation is said to be distance preserving if the distance between the images of 2 points is always equal to the distance between the pre-images of 2 points. The pre-images, remember, that's the beginning. Angle preserving, a transformation is said to be angle preserving if 1, the image of any angle is again an angle, and 2, for any given angle, the angle measure of the image of that angle is equal to the angle measure of the pre-image of that angle. So that's our vocabulary. Tomorrow we are going to do an activity, and I think we're going to have to do some of the problem set together. I don't think the lesson has prepared us very well to actually tackle some of the problem set, so we'll work on it together.